Hello everybody, today we are talking about the pH scale. So the pH scale is a scale used to measure the strength of acids and bases. Concentrated hydrochloric acid can burn through clothing and skins, while concentrated bases can also be very corrosive. Both are dangerous to your body if they are strong enough. However, HCl is also found in your stomach and baking soda is found in foods. So how can we decide how corrosive an acid or base is? To do this, the chemists use a pH scale. Here are some values that a pH might have and some examples of those chemicals at those values. Excuse me. Please notice that water is right here in the center of the scale, and water has a value of 7. So for this scale, looking at water at 7, drain cleaner down here nearly 14, and battery acid and stomach acid around 1, we can make the assumption or the interpretation here that this pH scale kind of goes in two directions. It goes more dangerous, more danger, and more danger. And then we have less and less. So the scale is actually sort of a two-direction scale with water in the center. Water is neutral. It is neither an acid nor a base, or in some cases you might look at it as being both. And all these other liquids are either more acidic or more basic. So this is more danger or more acidic in this direction. And down here we have more basic. And so we say that bases are from above 7 all the way to 14, and acids are generally considered 1 to 7, or from 7 down to 1. In this case, we do see the example of battery acid, so sometimes some scales you'll see will actually go to 0. 0 is actually an option in this case. So we can go all the way down to 0 in some extreme examples. Note the pH scale is pH is scaled in base 10. So pH is a base 10 system. That means that we are talking about the exponent of the number 10. So we're talking like 10 to the 1, which is just 10. 10 to the 2 would be 100. 10 to the 3 would give you 1,000. So if we were trying to compare some of these chemicals, we would say that let's say lemon juice, which is 10 to the power of 2, where pH is the 2, compared to apples, which is 10 to the power of 3. So that means that this is 100 and this is 1,000, or a factor of 10. Now I should actually indicate that there's some extra detail here that we don't really have to go through here, but it's actually -2 and -3, which is dividing dividing 1 by that number. So lemon juice is like dividing by 100, while apples is like dividing by 1,000. So would you rather have your money divided by 1,000 or divided by 100? Which one leaves you with more money? Well, this lemon juice leaves you with more money, or it's a larger number. So pH is each step of the pH scale is 10 times stronger, times 10 stronger. Okay. When we move backwards down the scale here, these are still times 10 in the other direction, although we are talking about the basic scale in this case. So this has an effect where pH can suddenly become very dangerous in the extreme ranges. And for human beings, we are most sensitive to bases. And so we start to find that right around this range here, humans start to be affected. And meanwhile, in acids are a little bit less dangerous to human body, so only after Only in the extreme edges of 2 are acids really damaging to our bodies. But for other chemicals like metals and things like that, even a little bit of acid is dangerous to those. So both acid and bases are dangerous, but it's all about concentration and the nature of the chemical. A low concentration strong acid may be as dangerous as a more concentrated weak acid. Some acids are not very strong, but still dangerous for other reasons. The word acid doesn't mean bad, but it does mean be careful. Remember that because humans are mostly proteins and fats, bases are more dangerous to us at lower concentrations than acids. And that's why bases start to be dangerous around 9 and acids are dangerous around the 2 mark. So a neutralization reaction is a reaction that will bring the pH to 7. A base and an acid can react together to form water and a salt. This type of reaction is called a neutralization reaction. It is a type of double replacement reaction. An example of neutralization is shown below. Here we have the acid and the base, and the acid and base part, which is the hydrogen and the hydroxide. Those come together to form water, and their partners, the chlorine and the lithium, come together to form a salt. Just move that salt so it points there. In the neutralization of an acid by a base, water is formed by the hydrogen ion from the acid and the hydroxide ion from the base. Water is pH neutral, which is why this reaction is called neutralization. Neutral products are made. The second product in a neutralization reaction is always a salt formed from the positive ion of the base and the negative ion of the acid. Since the hydrogen ion and the metal ion switch partners, neutralization is a double replacement. So let's write the neutralization reaction of hydrochloric acid and sodium hydroxide. Hydrochloric acid, HCl, we can look at our table from earlier, and sodium hydroxide. Added together, we're going to take the parts that make up water and use those to write out a water. And the other parts of the chemical reaction, the chemical partners, are going to be added together. And that's it. Here's our salt. Here's our water. And what I really like about these types of chemical reactions is that the products are always the same, always a salt and always a water. Now sometimes you might have a situation where you have a subscript that tells you there's more hydroxides or more hydrogens than before. The products are still the same, a salt and water, but the number of waters that you make might be different. So let's look at this example here. We're going to be combining hydrogens and hydroxides to make water. So that's all of these and all of those. And then we're going to combine calcium and fluorine, but we still have to use the rules that we used a long time ago to figure out the ratio of them. Doing that crisscross, I know that I need this to be CaF2. And now it's a matter of balancing the chemical reaction. So I'm going to go and figure out how to do that. I have one calcium. I have two hydroxides and two oxygens and only one oxygen over here. So I'm going to put a 2 there. That's going to give me 4 hydrogens, which is good because that's 4 hydrogens, so I'm good there. And the only thing I haven't checked is the number of fluorines, and I see the number of fluorines is not, oh, you know what? I could have done this from the hydrogen, couldn't I? So here's 2 of my hydrogens, but my other 2 hydrogens have to come from here, and I only have 1, so I'm going to put a 2 there. There we go. Okay, let's try this next one. We have H2S, and we know that this is neutralization. It's sulfide or sulfic, hydrosulfic acid, and barium hydroxide. So that's an acid and a base, and I'm going to combine them to make water, and then barium sulfide. And I have to do my check. +2 -2, that cancels out, so I'm fine. I don't have to do anything else tricky there. And now I just have to check if it's balanced. There's 1 barium here, 1 barium there. There's 2 oxygens here, but only 1 oxygen here. So I'm going to add a 2. That gives me 4 hydrogens. I get 2 from there and 2 from there. So check, check. I'm all good. I get 1 sulfur, and that sulfur is matched. Okay, let's clean that up. And there we go. All right, let's try this last one. We have a hydroiodic acid and aluminum hydroxide. So again, it's a neutralization reaction. I'll try to preload you with that information. Tell you ahead of time what are the balance of these neutralization reactions. And then we're going to take that aluminum and we're going to combine that with the iodine. Aluminum is +3, iodine's -1. So we have 3 iodines per aluminum. All right, double check my answer here. I'm going to start with the aluminum. I'll start over here with aluminum. Aluminum, 1 to 1, check. Go to the iodine. Iodine is 3 to 1. Uh-oh, so I'm going to add a 3. Go to the hydrogen. Hydrogen is, I've got 3 hydrogens over here, and I have 3 hydrogens over there, so that's 6 hydrogens. So we got 6 over here, and I have 2 right now, so I'm going to put a 3 to get 6 in total. That's okay. I'm going to double check my oxygens now. I have 3 oxygens and 3 oxygens. Check. So that's my checking mechanism. Just always keep moving in circles and circles and circles. You can double check your aluminum if you put any, but we didn't put any coefficients in front of the aluminums. All right, so you have some practice page here to work on, and I will fill those out and with the answer key afterwards, and possibly we'll come back and discuss some of these questions here as well, and then we'll come back for another video talking about the use of pH in some of its applications. Have a great day.